Solve the system of linear equations using row operations on the augmented matrix. This time we do not know if the system is inconsistent, dependent, or possibly has a unique solution. So we start with the augmented matrix. 3, 1, 0, 12. -4, 3, 1, 15, and 2, 5, 1, 0. This is a tricky matrix to work with because we don't have a 1 in the first column, which helps us choose which row will be an operator. This time I'm going to let row 3 be the operator and take -1 times row 3 and add it to row 1. This is actually going to give us a 1 in the first row, first column, which we will want for further processing. I'm also going to take 2 times row 3 and add it to row 2 to get a 0 in the first column's second row. So I'm going to have 1, -4, -1, 12, 0, 13, 3, 15, and 2, 5, 1, 0 as the equivalent matrix. Now I'm going to take -2 times row 1 and add that to row 3 and put that into row 3. So 1, -4, -1, 12, 0, 13, 3, 15, 0. 8 plus 5 would be 13. 2 plus 1 would be 3. And 24 plus 0 would be 24. Now I'll take -1 times row 2, add it to row 3, put that into row 3 so that we get a 0 in column 2, row 3. And that's going to give us 1, -4, -1, 12, 0, 13, 3, 15, and 0, 0, 0, 9. The last equation, or the last row, translates to the equation that 0 equals 9. And that is false. Therefore, the third equation has no solutions, and the system itself has no solutions. And so this system is inconsistent. We'll go to the next example. And the augmented matrix, -4, -1, 36, 24, 1, -2, 9, 3, -2, 1, 6, 6. So row 2 looks as if it's our natural operator. Let me interchange row 1 and row 2. So 1, negative 2, 9, 3, negative 4, negative 1, 36, 24, negative 2, 1, 6, 6. And then we'll take 4 times the new row 1, add it to row 2, make that the new row 2, and 2 times row 1, add it to row 3, and make that our new row 3. So we have 1, negative 2, 9, 3, 0, negative 9. Then we have 36 plus 36, which is 72, and 12 plus 24, which is 36. And 0, 5, 2 times row 1. Let me be careful there. 2 times row 1 would make the second entry negative 4, plus 1 would be negative 3. 18 plus 6 would be 24, and 6 plus 6 would be 12. And so at this point, we see that we could eliminate the negative 9 by taking negative 3 times row 3 and adding it to row 2 and put that into row 2. So we'd have 1, negative 2, 9, 3. We'd have 0, 0, and negative 3 times 24 is negative 72, so we get a 0. And negative 3 times 12 is negative 36, so we get another 0. And then we have 0, negative 3, 24, 12. So now we can multiply row 3 by negative 1/3. Put that into row 3 to get 1, negative 2, 9, 3, 0, 0, 0, 0, 0, 1, negative 8, and negative 4. We can then interchange row 2 and 3. To get 1, negative 2, 9, 3, 0, 1, negative 8, negative 4, 0, 0, 0, 0. This tells us there's going to be an infinite number of solutions. And first of all, we'll write the first two rows in terms of x, y, and z. So we have x minus 2y plus 9z equals 3, and y minus 8z equals negative 4. So this will give us y equals 8z minus 4, and x equals 2y, which is 2 times 8z minus 4, minus 9z plus 3. So we have 16z minus 9z would be 7z, and negative 8 plus 3 would be negative 5. So x is 7z minus 5. But we're going to let z equal t, so we're going to replace the z's by t's. And so our general solution will be 7t minus 5, comma, 8t minus 4, comma, t. And just to check out to see if this looks to be an appropriate answer, if t equals 0, we would get specifically negative 5, negative 4, 0. So that would give us positive 20 plus 4, which would be 24. It would give us negative 5 plus 8, which is 3. It would give us 10 minus 4, which is 6. And all of those would check out. But our general solution, because there are infinitely many solutions, is this. This is what we report.